Have you ever wondered why airplanes can fly? It's not magic, it's physics. Imagine an airplane cruising through the sky. What makes this remarkable feat possible are four fundamental forces, each playing a critical role in the art of flight. These are lift, gravity, thrust, and drag. Together they create a delicate balance that allows an airplane to leave the ground, stay airborne, and navigate through the air. Firstly, there's lift, the hero of our story, lifting the aircraft upward by manipulating air pressure. Then we meet gravity, the ever-present force that pulls everything back towards the Earth, keeping the flight grounded, figuratively speaking. Propelling the airplane forward is thrust generated by engines, whether they are roaring jets or spinning propellers. Opposing thrust is drag, the natural resistance provided by air, trying to slow the plane down. These forces must be perfectly balanced for an airplane to fly efficiently. When lift equals gravity and thrust equals drag, flight is achieved in its most elegant form. Now let's dive deeper into each of these forces and understand their roles. First, let's talk about gravity, the force that keeps our feet on the ground. This invisible force, ever present and powerful, pulls everything toward the center of the Earth. It's what gives weight to objects and causes them to fall when dropped. In the realm of aviation, gravity plays a crucial role. For an airplane, gravity is a constant downward force, always at work. It's what makes flight possible, yet challenging. As an airplane soars through the skies, gravity is the force that consistently pulls it towards the Earth. This isn't just about keeping the aircraft from floating off into space. It's essential for flight stability. The pull of gravity ensures that an aircraft maintains a stable flight path and aids in the predictability of its movements. Moreover, when it's time to land, gravity is the dependable force that helps bring the aircraft back to the ground safely and smoothly. While gravity tries to pull the airplane down, another force strives to oppose it. Now meet lift, the hero that lets airplanes rise above. Lift is a bit like magic, but it's all science. As an airplane moves forward, air flows over and under its wings. The wings are shaped and angled in a way that air moves faster over the top surface than the bottom. This difference in speed creates a lower pressure above the wing and a higher pressure below it. The result? Lift, the upward force that defies gravity. The shape of the wing, known as an airfoil, is crucial. The curved top and flatter bottom manipulate the airflow, maximizing the pressure difference. It's this clever design that allows an airplane weighing several tons to lift off the ground effortlessly. But lift isn't just about the wing's shape. The angle at which the wing slices through the air, known as the angle of attack, is pivotal. Increase the angle and the lift increases up to a point. However, if the angle is too steep, the air can't flow smoothly, causing turbulence and potentially a stall. Pilots can control lift during flight. By adjusting flaps and slats, which are surfaces on the wings, they can change the wing's shape and surface area. This allows for more or less lift, which is essential during takeoff, flight and landing phases. So while gravity pulls down, lift counters it by pulling up. But what moves an airplane forward? To move forward through the skies, airplanes rely on thrust. This essential force is not just about power, it's about overcoming the relentless resistance that air presents. Whether it's a small propeller-driven aircraft or a massive jetliner, the principle remains the same. Thrust moves an airplane forward. Thrust is generated in two primary ways. In propeller-driven aircraft, engines rotate the blades of the propeller. These blades cut through the air, pulling the aircraft forward as they spin. Think of it as somewhat akin to swimming strokes, where each motion pushes against the water to propel the swimmer forward. On the other hand, jet engines work on a different principle. They suck in air at the front, compress it, mix it with fuel, and then ignite it. The resulting explosion of hot gases rushes out of the back of the engine at high speed. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. The fast-moving gases shooting backward propel the airplane forward. This reaction is what provides the thrust needed to cut through the sky. Pilots can control this powerful force by adjusting the engine's power output. During takeoff, they ramp up the thrust to maximum to lift the heavy aircraft off the ground. In contrast, during landing, the thrust is reduced to allow for a gentle touchdown. Thrust propels an airplane forward, but another force works against it. While thrust pushes an airplane forward, drag tries to hold it back. Imagine an airplane slicing through the air. As it moves, it encounters resistance from the air itself, a force known as drag. This isn't just a simple setback. Drag is a complex phenomenon that plays a critical role in flight dynamics. There are primarily two types of drag that affect an aircraft: parasitic and induced. Parasitic drag, also known as form drag, arises from the friction of the air flowing over the aircraft's body. It increases with the square of the aircraft's speed, meaning that as an airplane goes faster, the resistance it faces grows exponentially. This type of drag is heavily influenced by the shape and texture of the aircraft. On the other hand, induced drag occurs due to the creation of lift. Wings push air down to lift the airplane up, but this action also causes air to swirl at the wingtips, creating vortices that increase resistance. Unlike parasitic drag, induced drag is more prevalent at lower speeds, particularly during takeoff and landing. Aircraft designers work tirelessly to minimize these drags. Sleek, streamlined designs help reduce parasitic drag, while advanced wingtip devices, like winglets, cut down on induced drag. These innovations not only enhance speed, but significantly improve fuel efficiency, making modern aircraft both faster and greener. Despite its challenges, drag is a crucial factor in safely controlling the airplane's speed and descent. So how do pilots master these forces to fly safely and efficiently? Pilots, as navigators of the skies, have the intricate task of balancing the four cardinal forces of flight: lift, gravity, thrust and drag, to command their aircraft through various conditions. Understanding and managing these forces are not just about keeping the aircraft airborne. They're about precision, efficiency and safety. Starting with lift, pilots adjust the angle of attack of the wings to maximize this force when needed, especially during takeoff and landing. This is critical since lift must counteract gravity, the relentless pull towards Earth. Pilots must continuously evaluate and adjust to ensure that lift sufficiently opposes gravity, maintaining altitude or ascending or descending smoothly. Thrust, generated by the aircraft's engines, whether propeller-driven or jet, propels the airplane forward. Pilots must decide the amount of thrust necessary for different phases of the flight. Too much thrust can lead to excessive speed and fuel wastage, while too little can cause the aircraft to stall. Meanwhile, drag acts as the natural resistance against the forward motion. Pilots must understand how to minimize drag by maintaining an optimal speed and using the aircraft's flaps and gear judiciously to reduce resistance. Advancements in technology and rigorous training have equipped pilots with tools and knowledge to make informed decisions. Modern aircraft are outfitted with sophisticated instruments that monitor these forces in real time, allowing pilots to make adjustments swiftly and accurately. Every maneuver, whether a gentle cruise or a sharp turn, requires a delicate balance of these forces. Every flight is a precise dance of physics where lift, gravity, thrust and drag play their parts to perfection.
Smash subscribe, hit the bell, never miss out.